Question 39. The diagram shows the structure of a polymer. Which structure represents the monomer of this polymer? Now, when we look at all of these bonds, they are single bonds between the carbon atoms. Okay? This must be coming from an addition polymer. So what we do, we break this one here. You bring it back here. You also do the same here. Take this one here. Okay? Bring this one back here. Okay? Then break again. Come here. Then here. And there. Now let's write what comes out. So this one is broken because when we are forming the polymer, the double bond which is here opens up like this. Opens like this. And then the other one also comes like that. So that is how they do it. Now, we are going to have this one here. Then there is a CH3 here. So let me put it here. Then there is this hydrogen. Now there is a double bond which is formed here. Then there is this carbon. And then up here there is a hydrogen. Then down there is this group here. The aldehyde group, we call it the aldehyde. So I will say CHO. Okay. Or I can leave it the way they gave it, just like that. Okay. So this one I've taken. Of course, now this bond has been broken. Now look at this other one here. So this one here, we are having the same thing. Carbon here, look at this one. There's a CH3 connected. Hydrogen here. Then another carbon which is connected to it, but then there is a double bond formed here. Then there is a hydrogen. Then this one is up. It is just, they just changed the orientation. Now in A level, you learn about what we call stereoisomers, okay? The cis and trans. When the hydrogens are on opposite sides of this plane, that is a trans. And then when they are on the same side, if you put the hydrogen here, then you take this one here, that will be cis, okay? But that one, you learn it in A level. But all of these ones, we are seeing three molecules. This one here, there's a double bond here, this one broken, it's all the same as this. So we are seeing this polymer here formed from three monomers of this one here. So when we check here, we can see a C. Let me reduce this a bit. So you can see C here with the H, then connected to CH3. That is the same here. Then there is a double bond, which is here. Then the carbon and then the H. That is the one there. And then the CHO. This. So that means our answer is actually C. Then question 40. Which piece of apparatus is used to measure 24.5 cubic centimeters of gas produced during a reaction? Okay, of course, when we look at the conical flask, this one measures aqueous. So here we are looking at aqueous compounds, okay? Compounds. In other words, we look at liquids. The beaker, the same thing, okay? The beaker, the same thing. We cannot use a beaker to do it, to measure the gas. Volumetric pipette, the same thing, okay? Volumetric pipette. When you can pipette, like the pipette looks like this, then it has something here, so it comes like this, and then it has a mark there. So maybe this one is 25 cubic centimeters. So you can use a pipette filler, or you can suck with your mouth. You see? So that one is also for aqueous. So meaning that the one that is left is, of course, the measuring cylinder. Piece of apparatus used to measure this of a gas during a reaction. So this can be a measuring cylinder. Even this one uses aqueous compounds, but we can invert it in the reaction. You have something like this. So this is your measuring cylinder here, and then you have a delivery tube in here that enters here. Then you find that the gas comes off, okay, and then it is measured up there. So this one is very possible, okay. This one here is very, very possible. So it has to be the measuring cylinder. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.